Construct the minimal DFA for strings over A's and B's where each string is ending with AB. Given alphabet is A, B and language is set of all strings where each string is ending with AB. So the minimal string is AB and the other strings are AAB, BAB, AAAB, ABAB, BAAB, BBAB and so on. And these are the strings which are in the language and we need to construct a DFA to accept these strings. The strings which are not in this language are to be rejected. Since sigma is not in our language, the initial state will not be the final state. So Q0 is our initial state, let's say, and consider the minimal string AB to construct the skeleton of a DFA. So on seeing A, we move to state Q1. From Q1, on seeing B, we move to state Q2 and accept this string. So Q2 is a final state. This is the skeleton to accept strings which are ending with AB. Now we can construct the complete DFA by including the missing transitions over each state. For construction of DFA, there are two ways. One way is to consider each string and construct the DFA to accept each of these strings. Add missing transitions over each state so that each of these strings is accepted and the strings which are not in this language are rejected. Let's see how to construct the DFA for this language. Now consider the string AAB. From initial state Q0, on seeing A, we move to Q1. From Q1, on seeing A, we will be in Q1 only, because no matter how many A's I see at Q1, I will not be going to the final state except when I see B. On seeing B, from Q1, we go to Q2 and accept this string. Strings like A, B, 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 all these strings are in this category. Like from Q0, we see an A and go to Q1 and we see a series of A's and we will be in Q1 itself. On seeing B, we go to Q2 and accept this. Same goes with all these strings. Like on seeing A, from Q0, we go to Q1. No matter how many A's we see at Q1, we will be in that state only. Once we see a B at Q1, we go to Q2 and accept this. Now let's consider BAB. String BAB. On seeing B, from state Q0, I will be in this state only. And on seeing A, from Q0, I will go to Q1. From Q1, on seeing B, I will go to Q2 and accept this string. The strings like BBAB, BBBAB, BBBB, AB, all those strings starting with B, a series of B's and ending with AB are in the language and they come under this category. So no matter how many B's I see, I will be in Q0 only, and once I see an A, I will move to Q1 and at Q1 if I see B, I go to Q2 and accept this string. The string AA is already covered in this case. So this is done. Now consider AB. On seeing A from Q0, we move to Q1. Q0 to Q1. On seeing B from Q1, we move to Q2. From Q2, if I see an A, I should go to that state from where I will have AB as my end of the string. So from Q2, if I see an A, I should go to Q1. This essentially means the transition from Q2 to Q1 over A and Q1 to Q2 over B is equivalent to this accepting the strings ending with AB. So Q2 is my final state. So if I have AB at the end of the string, I will accept it. This is what this signifies, these two transitions. So we accept AB. Now again let's parse this string once more. On seeing A from Q0, we go to Q1. On seeing B from Q1, we go to Q2. On seeing A from Q2, we go to Q1, and on seeing B from Q1, we go to Q2 and accept this string. Now let's consider the string AB and try to add missing transitions to accept this string, because this is ending with AB and this is in our language. So on seeing A from Q0, it goes to Q1. On seeing B from Q1, it goes to Q2. On seeing B from Q2, we should go to that state from which we will be seeing AB at the end of the string and accept it. If we don't see AB at the end of the string, we will be rejecting that string. So if we have a string ABB, we should be rejecting this string because this is not in our language. So from Q2, we should go to some state where if we see AB after this, this is a valid string. So this should be accepted. So we move to that state Q2 to Q0 on B so that we will have AB as our end of the string. So if we parse this again, we can see on seeing A from Q0 we move to Q1, on seeing B from Q1 we move to Q2, and on seeing B from Q2 we move to Q0, and when we see an A from Q0 we go to Q1, and when we see a B from Q1 we go to Q2 and accept this string. AB is accepted. This is how we construct a minimal DFA for strings ending with AB. There is another way to construct the DFA, which is to consider each state and check whether each state is complete or not. By complete I mean check whether each state has transitions over A and B, the input symbols. Each state should have transition over each input symbol. With that criteria, we should be able to draw a DFA.